Hi everyone. So the goal of this video is to look at two-dimensional force with gravity. And when I say two-dimensional force, I mean not just up and down and side to side, but also what if we're dealing with some kind of angle? When we look at a lot of the structures that are built in everyday life, we have things at all kinds of angles. It's not always up and down and side to side. So it's important to understand forces that might not be applied at, perfect 90-degree angles. So let's start off with an example. This is a very simple example. You'll see this in a lot of physics textbooks. Just a block on a ramp. And what are the forces acting on that block? And if you can understand this idea, then you can start applying this concept to more difficult problems or more real-world problems. Let's start off with this simple example here. We have a 1 kilogram block. It's on a ramp, and the ramp's at an angle of 15 degrees. We want to find the net force acting on the block and maybe even the acceleration of the block. All right, so let's start with number one right here. All right, so we can draw a free body diagram. And typically when we draw a free body diagram, we have some kind of object and we have some of forces being applied to it or gravity or whatever, and maybe a normal force and all that. Now we can try to draw that same idea, except we're going to have to draw it at an angle, and that's going to change a few things, and we're going to have to use a little trigonometry. So what that would look like for us is we're going to have something that looks like this. I'll try to draw it accurately. Maybe that might be about 15 degrees. So this angle here is about 15 degrees. And we have a block on the ramp. All right. Now we want to figure out what forces are acting on this block and what's going to happen to the block. Now intuitively, if we know that the only thing really acting on this is gravity and the normal force, and there's no friction, we're not dealing with friction quite yet, then we would expect this block to slide down the ramp. All right. Now it's not going to fall like it would if we just dropped it, just dropped it and let it fall because of gravity. But gravity is going to make it slide down the block, and it might slide down slowly because this angle isn't very steep. So intuitively, that's what we're going to be looking for here. And so when we get our final answer, keep in mind that we should end up with some kind of force that's pulling this block down, and that force is going to be related to gravity. So let's draw our free body diagram. Now we know that gravity is going to be going downward. All right, and we can see that, well, it can't exactly go downwards because we have an angled surface. So what we're going to do is we're going to break this force of gravity, into two components. We have a y component here, and then an x component here. So we're going to break this down into its two components. All right. And now this component here, this one is perpendicular to the surface of the ramp. All right. And so the forces that are perpendicular to the ramp, we have a force of gravity in this direction, and what's also perpendicular to the ramp is our normal force. All right, so we can call this over here, this is the force of gravity in the y direction, and this is the force of gravity in the x direction. All right, now from here we can start to actually plug in some numbers. All right, so we know that the force of gravity is equal to our mass times the acceleration of gravity. For us, the mass was 1 kilogram and the gravity was negative 9.8 meters per second squared. So that's going to equal negative 9.8. So that is the force of gravity. Now we're going to take this force and we're going to break it down into its y and x components. Now to do that, for the force of gravity in the y direction, well, we have to take this number and then we have to multiply it by like cosine or sine of our angle. So let's take a look at that really quickly. So I'm going to have my calculator here. So if we take negative 9.8 and we do sine of 15, all right, so we get negative 2.5. All right, that is the force in the x direction. So let me just slide that over here. So we're going to have to find both of these, force of gravity in the x direction and force of gravity in the y direction. In the x direction, we would take our negative 9.8 and we would do sine of 15. And then our y component is going to be negative 9.8 cosine 15. All right, so this one is negative 2.5, and then this one is, let's see, negative 9.8 cosine 15. Negative 9.5. Okay. So we found our two components here. So up on our picture, the y component is negative 9.5. The x component is negative 2.5. So I hope that makes sense intuitively in terms of how much of the force of gravity is making the block slide down the ramp. Now, gravity isn't going to be able to accelerate it at 9.8 meters per second squared. Like I said, that would be if it was falling straight down without being on a ramp. But because it's mostly supported by the ramp and the angle isn't very steep, only some of gravity's force is going to be making this block slide down the ramp. So we can imagine that the block is sliding down and the force of gravity is this much here, 2.5 newtons. All right, and then going back to the question of, okay, well, like, what is the acceleration of the block? Well, if we know that the force of gravity in the x direction is negative 2.5, and if we know that the mass of the object is 1 kilogram, and we're trying to find what is the acceleration. Now, what we know from our picture here is that the normal force and the force of gravity in the y direction, those two things will cancel out. So we don't need that in our calculation. The only net force, the only force that's related to our net force is this one, the force of gravity in the x direction. All right, and so from here we can do a simple F equals ma. So we have negative 2.5 newtons is equal to, just move the calculator really quickly, 1 kilogram times A. And so from here you probably can see it's pretty simple, where if this is 1, then we're dividing both sides by 1, which doesn't do anything. So acceleration is also negative 2.5 meters per second squared. And so this is how much the block would accelerate down the ramp. All right, so one other thing I'll mention really quickly is that was the example for this ramp here at 15 degrees. If you were to make this angle steeper and steeper, the portion that's in the x direction would get bigger and bigger, and the object would fall faster and faster, and the force of gravity in the x direction would get bigger and bigger. So I'll just do a quick example of that on the side here. Let's say we had a ramp that was very steep, like this, and let's say this angle is like 75 degrees, and we try to put a block down this ramp. I mean, that block is practically falling. I mean, it would probably barely slide on this ramp. Or when I say barely slide, I mean it would almost barely be touching this ramp. It's almost like it's in free fall. And so you can imagine, if that's the case, a large percentage of the force of gravity is in the x direction. We'll treat this as the x direction. We'll treat this as the y direction. All right, and therefore the force of gravity in the x direction would be higher, and then this object would fall faster. And again, I hope that makes intuitive sense, where this block should be falling a lot faster than this block. All right, so that's just an example of forces in 2 dimensions, especially when you're dealing with things at an angle. If this problem was confusing, I can definitely work with you in class. But this was something that you might see on a college level. If you take college level physics, you'll probably have to deal with these 2-dimensional force problems. So I want you to be exposed to that before you get to college, if that's the route you're on, and I hope you choose to accept this challenge. I will make this an assignment, and I'll give you some practice questions that will probably be like an aspire to activity. But I thought it would be good to introduce you to this concept now. All right, good luck with these problems if you so choose to try them.